In this class, we are going to discuss about the solution of the CAT that we did on 29th November 2024 in Millennium Hall 1. So, but before we discuss the CAT solutions, I'll briefly go through the performance. So this class has 199 students with 5 different groups. So 23 students missed to do the CAT. So these are the summary statistics for 176 students. So the mean is 50.7%, mode 60%, median 50%, and these are other measures of dispersions and variations. So the range is 78, where the highest student scored 88%, and the minimum score is 10%. Here we have a histogram that gives a summary of the overall performance. So we can clearly see that a majority of students scored around 40% to 70%. So the curve is normally distributed. But we want to ensure that those who are below 40% are moved towards 40% and above. So here is the list of the top performers. The highest score of 88% was scored by Wambui Maslin. The second highest was James Kanyora. The third highest score of 82% was by Matthew Kipkoech. And we have these other top performers. So the whole class, we had 17 students getting a mark of 70% and above. So if this was the final exam, then it means that the class will have 17 cleaners. But even if you're not on this list of 17, you can still work harder to be part of this group in the final exam. So let's go directly to the questions and see the solution that you're supposed to have obtained. Just as a disclaimer, when I was marking the CAT script, I was over-lenient, but this will not be the same case for the final exam. So I encourage you to go through these solutions and take note when you receive your CAT script, write the solutions and then check where you are making mistakes and correct them so that you don't repeat during the final exam session. So the first question 1A, a particle acted up by constant forces 3i minus 2j plus 2k and 2i plus j minus k is displaced from the point 1, 3 minus 1 to the point 4 minus 1 lambda. If the work done by the forces is 16 units, find the value of lambda. So this is a question testing on application of dot product. So the first thing we need to find the resultant force, and the resultant force will be given by just the sum of these two forces. So when you get the sum of these two forces, we have 5i minus j plus k. And then we need to get the displacement, moving the particle from this point to this other point. And then in terms of the unit vectors I, j, and k, we'll have 4i minus j plus lambda k minus I plus 3j minus k. And this will be our displacement vector. Now the work done is given as 16 units, and work is always force times distance. So the dot product of force vector and displacement vector will give us 16. So we dot the force vector and the displacement vector. So we form this equation, and then using the dot product formula, multiply or get the sum of the product of the corresponding components. So we'll get that lambda plus 20 equals to 16, and lambda is minus 4. So these are the marking points how we were supposed to get the 3 marks. Then the next question is, u is x plus y plus z, v is x squared plus y squared plus z squared, w is yz plus zx plus xy. So we are asked to prove that the gradient of u gradient of V and gradient of W are coplanar vectors. So one thing that you have to remember is that three vectors will be coplanar if the scalar triple product is 0. So by definition, the gradient of U is given by this. So we'll have I, J, K. Gradient of V by definition is given by this formula. So we have 2xi plus 2yj plus 2zk. Gradient of W using the definition will be given by z plus yi plus z plus xj plus y plus xk. So those are the gradient vectors. Then by definition, for the vectors to be coplanar, then their triple, the scalar triple product should be 0. And by definition, now we'll have this. This is how we define the scalar triple product. Gradient of U dot the cross product of gradient of V and W. So this first will be given by, we have the definition of the scalar product. So we have 1, 1, 1, the components of this grad U vector. Then we have these are components of the second vector, and then these are the components of the third vector. This is the way we define the scalar triple product as a vector. Then once we have this, we use properties of determinants. So this second row has 2 as a common factor. So we factor outside the determinant. So we'll have 2 times the determinant of this new matrix, where the second row elements will be x, y, z. And then we can simplify this determinant by saying, let's add the row 2 to row 3 to define our new row 2. So that now row 2 plus row 3. So this first element here is x plus z plus y will be x plus y plus z. Similarly, y plus z plus x will give us x plus y plus z. Similarly, z plus y plus x will give us x plus y plus z. So we retain row 3 the way it is. Then, as we can see, the second row has common factor of x plus y plus z. So I can also use property of determinants and factor it out. This from linear algebra. So factoring out x plus y plus z will have 2 into x plus y. This will actually, this not be, this equal sign should be before 2. So just have here, it's a type of error. This will be this times this determinant. This equal sign should be before 2. Now, from the property of determinant that when we have 2 rows which are identical, then the determinant is 0. Then this determinant collapses to 0. And so 0 times 2 into x plus y plus z is 0. So since the simplification of the scalar triple product of the gradient of U, gradient of V, and gradient of W is giving us 0, then we conclude that the gradient of U, gradient of V, and gradient of W are coplanar vectors. So these were the marking points. So C, find the directional derivative of x squared plus x squared, y squared, z squared at the point 1, 1 minus 1 in the direction of the tangent to the curve, which is parametrically defined as x equals to e power t, y equals to sine 2t plus 1, z equals to 1 minus cos t, at the point t equals to 0, or at time t equals to 0. So by definition, the directional derivative of a scalar function f in the direction of a vector v is given by this. So gradient of f dotted with the vector v. So where this v is a unit vector in the direction of the vector v. So check or note the way we are writing the unit vector. This is a cap above the v. So first now we calculate the gradient of this function x squared, y squared, z squared. So this is the partial f, partial x. This is by definition, this is partial f, partial x, this is partial f, partial y, this is partial f, partial z. And then, so by definition, this is how we write the gradient. Or if you like, you can as well express that vector in terms of the unit vectors I, j, and k. Now get the derivatives of this parametric curve. So partial dx dt is given by this, dy dt, dz dt is given by sine of t. Then define the values of these derivatives at t equals to 0, and then the unit tangent vector at t equals to 0 is this vector with these components 1, 2, and 0. So this is a tangent vector, not the unit tangent vector. So then, which means to get now the unit vector in the direction of this vector v, you simply find the magnitude of v and then divide by each of the component of the vector v. So this is how we define the magnitude of v, which is root 5, then divide by each component of the vector v. So therefore now by definition of the directional derivative of a scalar function f, which is given by the gradient times the unit tangent vector, is given by this. So we'll have that scalar product, and when you substitute in the values, we'll get that the directional derivative in the direction of f, the directional derivative of the scalar function f in the direction of the vector v is given by 6 over root 5. And then we get those 3 marks. D, find the unit normal to the surface x, y power 3 z squared equals to 4 at -1, -1, 2. So the first thing is to find the gradient of the surface given by f equals to 0 to give now the vector normal to the surface. So this is how we define the gradient by definition, and then we'll have y cubed z squared as the component of I, then component of j will be 3xy squared z squared, component of z, 2xy cubed z. Then now, when you substitute the value of x as -1, y as -1, z as 2, we get that the gradient will be -4 as the I vector, -12 as a j vector, and 4 as a k component as the component of the k vector. So thus, this would be the gradient at the point specified -1, -1, 2. So if you like, you can write this one as -4i minus 12j plus 4k. Then get the magnitude of this gradient. So it should be given by 4 root 11. And then the unit normal will be given by the gradient vector divided by the magnitude of the gradient vector. And this is what you'll have. When you simplify, this is the unit normal vector. Then the next question is to find the values of the constants m and n such that the surface mx squared minus 2n yz equals to m plus 4x will be orthogonal. So orthogonal means perpendicular to the surface 4x squared y plus z cubed equals to 4 at the point 1, -1, 2. So remember, this given point is on both surfaces, because the two surfaces are meeting. So when we substitute the values of x, y, and z in this surface, we get an equation which will help us to simplify the value and values of which will simplify this equation in terms of m and n. And on simplification, we find that m and m cancels out and n will be 1. Then we let this first surface scale it phi 1 and let this other surface call it phi 2. So let's get the normal to the first surface, and the normal to the first surface is the same as, let's get the gradient of this surface and then get the value at the specified point 1, -1, 2. So this is how the gradient of phi 1 is. And then when you substitute 1, -1, 1, -1, 2, then this will be the normal to the first surface, which we are calling phi 1. Similarly, do the same thing for the second one, and then the normal to the second surface at the point 1 minus 1, 2 is minus 8i plus 4j plus 12k. So then now, since these two surfaces are orthogonal, to mean that they are perpendicular, then their normals must also be perpendicular. And by definition, the dot product of two perpendicular vectors should be 0. So this is the condition we are using. And then when you substitute in the values and simplify the dot product, we get that the value of m is 5. So m is 5, n is 1. Then f v is given by xi plus yj plus zk divided by square root of x squared plus y squared plus z squared. We're asked to find the value of the divergence of v. So by definition, if we have a vector field or vector function, fi plus gj plus hk, then the divergence of v is given by partial f partial x plus partial g partial y plus partial h partial z. So where this is f, the I component, this is g, the j component, and this is h, the k component. Then we get the partial derivatives, partial f partial x. So this we use quotient tool because we have a quotient of two functions, x and v square root. So u prime v minus v prime u by v squared. So u is x, then v is this denominator, which is a function involving square root. So when you differentiate partially this with respect to x, you get 1, multiplied by the denominator, we get this, minus, when you differentiate this partially with respect to x, by chain rule, we will get 2x, and then this raised power minus a half, and then when you rearrange it, we'll have now 2x multiplied by, okay, so we'll also need to multiply that by a half, so that half and 2 cancels out, so we'll have v prime u will be x times x over square root of this, divided by the square of this is just everything without the root sign. And when you simplify, you get this at the answer. Similarly, partial y, partial g, partial y will be given by this, and partial h given by this function, and partial h, partial z will be given by this. Then when you replace this sum or these partial derivatives in the formula for the divergence of v, we get 2 into x squared plus y squared plus z squared, then divided by this raised to power 3 over 2. And then this and this cancels out, then we have 2 over square root of x squared plus y squared plus z squared as the simplified expression. G, if u is x squared plus y squared plus z squared, and r is xi plus yj plus zk, then find the divergence of u times r in terms of u. By definition, if we have a vector field given by pi plus qj plus rk, then the divergence of f will be given by partial f, partial p, partial x, plus partial q, partial y, plus partial r, partial z. So if, or the vector function whose divergence we need to define is u times r. So u is given by this in the equation, and r is given by this in the equation. So when you multiply, you get that p is ux, which is given by this function, q is uy, which is given by this function, r is given by uz, which is given by this function. So partial p, partial x, you get the partial derivative of this. And when you simplify using product rule, or when, if you like, you can expand and then just do the partial derivative termwise, you get 3x squared plus y squared plus z squared. Similarly, partial q, partial y is x squared plus y, 3y squared plus z squared. Similarly, partial r, partial z is x squared plus y squared plus 3z squared. So we put all these partial derivatives together in the formula for divergence, and we get 5x squared plus 5y squared plus z squared. 5 is common, so when you factor out 5, you'll have 5 into x squared plus y squared plus z squared. And then x squared plus y squared plus z squared is u by definition. So it means that the divergence of u times r is nothing but 5u. Then h, find the value of n for which the vector r power n times r vector is solenoidal, where r is xi plus yj plus zk. Please know that when we write r with an arrow on top, it is a vector. And when you write r without the arrow, it means the magnitude of the vector r. So a vector field is said to be solenoidal if the divergence is 0. So for this vector to be solenoidal, then we need to show that the divergence of the vector r power n times r vector is 0. So r is by definition the magnitude of vector r, which is square root of x squared plus y squared plus z squared. So by definition, this is the divergence of the vector field f given by pi plus qj plus rk. So p is r power nx, q is r power ny, r is r power nz. So partial p partial x with partial x of r power nx. Then you change r in terms of x, y, and z. This is what you'll have. So when you use product rule, this is what we'll have as our solution. Similar procedure will give you this as our value for partial q, partial y, and this as the value for partial q, partial y, and this as the value for partial r, partial z. Then we sum those three partial derivatives, and we get the divergence of this vector f is n r power n minus 2 times x squared plus y squared and plus z squared plus 3 r power n. But we know x squared plus y squared plus z squared is r squared. So you can replace this in terms of r. So then the divergence of f reduces to n plus 3 r power n. Now, for this vector field to be solenoidal, then it means that the divergence should be 0. So equate this quantity to 0. And for this to be 0, assuming r is non-zero, then this coefficient must be 0. So n plus 3 is equals to 0, so which means that the value of n must be minus 3. There are three vectors, a, b, and c. So we need to find the cross product of a and b, then by c, then a by b by c. Then we check whether the cross product of the three vectors is whether all of them will give the same value or the order of bracketing affects the final solution. So by definition, A cross B is given by this determinant ijk, then second row you write the components of first vector A, third row you write the components of the second vector B. Then using cofactor expansion, so we'll have A cross B will be I times this submatrix minus J this submatrix, this subdeterminant, plus K multiplied by this subdeterminant. So this is a simplification of the three subdeterminants. And so A cross B will be 7i minus 0j minus 7k, which is just the same as 7i minus 7k. So A cross B cross C, then now this one vector is 7i minus 0j minus 7k. So the same definition of the cross product, we write the determinant ijk, second row, the components of the first vector, which will be now be 7 minus 0 minus 7. Components of ijk for C vector is 2 minus 5, 1. Similarly, use cofactor expansion for this. So we'll have I times this subdeterminant minus j times this subdeterminant plus k times this subdeterminant. And these are 2 by 2 determinants which are not hard to evaluate. We have first subdeterminant is minus 35, followed by 21, followed by minus 35. So the final solution will be minus 35i minus 21j minus 35k. Then the other way around, we get the cross product of B and C. So by definition, this is what we have. Similar process, get this use cofactor expansion, and then we'll have this. Get the value of these subdeterminants, and B cross C will be 14I plus 3J minus 13K. So now A cross the value we have obtained above for B cross C, right? Similarly, write the determinant IJK, then components of the vector A, then components of the B cross C, which is 14, 3 minus 13. Do the same process of cofactor expansion. So we'll have this. Compute each of the two by two subdeterminants, then we'll have this. So A cross into B cross C will be minus 3I minus 54J minus 38K. So now we can compare the results. Into brackets A cross B, close brackets cross C, we got minus 5I minus 21J minus 5K, while A cross into B cross C is minus 3I minus 54J minus 48K. It's very clear, even a blind person can see that the two vectors are not equal. So therefore, into brackets, A cross B cross C is not equals to A cross B cross C. So order matters in the cross product. So now we go to question 2. If 2I minus J plus 3K, 3I plus 2J plus K, and I plus MJ plus 4K are coplanar vectors, find the value of M. So what we do, we give the three vectors the names V1, V2, V3. And for now, these three vectors, V1, V2, V3 to be coplanar, then their scalar triple product is 0. So this is a property we are testing on. So by definition, the scalar triple product of the three vectors, V1, V2, V3 is given by this. So which is just given by this determinant. For V2 cross V3, this determinant, when you get the solution, which will be given by 8 minus M, I minus 11J plus 3M minus 2K. Then calculate the dot product V1 and crossed with this vector V2 cross V3, we multiply the corresponding components, then get the sum. And when you simplify, you get M to be minus 3. Then 2B, show that the vectors A, B, and C are coplanar. So coplanar means the scalar triple product is 0. So the same thing we have done in the previous example. So by definition, you define this scalar triple product, then find the cross product of B and C using the determinant in the usual way. So when you work out this determinant, you get that B cross C is minus I plus 8J plus 5K. So when you dot with the vector A, so we'll have this vector A dotted with the B cross C, we get 0. And because now the value is 0, then we conclude that A, B, and C are coplanar vectors. So that's the condition for three vectors to be coplanar. So 2C, they find the magnitude and direction cosines of the torque about the point 2, 0, minus 1 of the force 2I plus J minus K, whose line of action passes through the origin. So let A be the point 2, 0, minus 1. Then the position vector of A, by definition, is this 2I plus 0J minus K, which is the same as 2I minus K. And therefore, the displacement vector R in the opposite direction of vector OA will be AO, which will be minus 2I plus K. So the given force is 2I plus J minus K. Let's call it F. Then by definition, the torque is given by R cross F, which is defined as this determinant. And when you work out the determinant, you get torque is minus I plus 0j minus 2k, or simply minus I minus 2k. Then get the magnitude of this torque, get the magnitude of this vector, which is root 5, and then the direction cosines are simply you divide each of the torque component by the magnitude of the torque, and then the components themselves of the unit vectors ij and k are what defines the direction cosines. Therefore, the direction cosines are minus 1 over 5, 0, minus 2 over 5. So D, if A is minus 3i minus j plus 5k, B I minus 2j plus k, and C 4j minus 5k, find A dot B cross C. This is the same thing as find the scalar triple product of these three vectors. So we'll start by defining B cross C, which is given as this determinant. In the usual way, find the value of the determinant, which will be 6i plus 5j plus 4k. Then dot this vector with vector A, and this is what you'll have. So multiply corresponding components and get a sum, we get minus 3. So that is the value of the scalar triple product of A, B, and C. Then E, find the vector and Cartesian equations of the plane passing through the point with position vector 4i plus 2j minus 3k and normal to the vector 2i minus j plus k. So given the point with position vector 4i plus 2j minus 3k, and so the normal, also the normal is given, which is 2i minus j plus k. And you know by definition that the general vector equation of a plane is given by the position vector r times the normal to the, which is given by n. So this is the same as p naught dot n as given in this definition. So r is xi plus yj plus zk is a position vector in the usual way. The normal is given as 2i minus j plus k. So substituting these values of r, n, p naught, and n in the equation, we have this is our r, this is our n, so it should be the same as this is our p naught, this is our n. So now when we calculate the dot product, we'll have 2x minus left-hand side, 2x minus y plus z. So right-hand side will give us 3. So the vector equation of the plane will be given by this, r dot this normal equals to 3, while the Cartesian equation of the plane is just in terms of x, y, and z, which will be 2x minus y plus z. F, find the equation of the plane passing through the intersection of the planes 2x plus 3y minus z plus 7 equals to 0, and x plus y minus 2z plus 5 equals to 0, and is perpendicular to the plane x plus y minus 3z minus 5 equals to 0. So the equation of, there are two ways of doing this one. So this one way. So the equation of a plane passing through the intersection of the two given planes can be given by this. The first plane, and then plus a scalar lambda times the second plane equation equals to 0. So when you simplify collecting like terms, then this is what you'll have. Then since this plane is perpendicular to the given plane, x plus y minus 3z minus 5 equals to 0, then the normals to these two planes are also perpendicular to each other. So we can always find the normals are always, the components of the normal vectors are actually the x, y, z coefficients. So 1 times this 2 plus lambda plus 1 times 3 plus lambda plus minus 3 times minus 1 minus 2 lambda equal to 0, because the dot product of two perpendicular vectors is 0. So that's why we have this equation. So this simplifies to this equation, and when you work out, you get that lambda is minus 1. So Here is also another way of doing the same question. I think you can follow through and still arrive at the same value of lambda being -3. And when now you put that, you get the equation. The required equation is 2x plus 2y plus z plus 2 equals to 0. So the next G question is find the divergence and curl of the vector V, which is given by x, y, z, I plus 3x squared yj plus x z squared minus y squared z k at 2 minus 1, 1. This is the definition of divergence if V is defined as pi plus qj plus rk. So when you work out accordingly with P given by this, Q and R, you get that the divergence are this. The general divergence value will be yz plus 3x squared plus 2xz minus y squared. And when you substitute the values at the specified point, x for 2, y for -1, and z for 1, you get that the value of the divergence is 14. Now, this is the definition of curl of the vector V. So when you work out this partial derivatives and you put in the formula for the curl, you'll find -2 yzi minus into z squared minus xyj plus into 6xy minus xzk. So at the specified point, you replace x for 2, y for -1, z for 1, and the curl reduces to 2i minus 3j minus 14k. Then find the constants a, b, and c so that this vector is irrotational and find the constants a, b, and c so that the vector f is irrotational, and hence find the scalar function such that this vector field f equals to gradient of phi. So the test for a vector field to be irrotational is the curl must be 0. So we need to define the curl of f and equate to 0 vector. So this is the definition of the curl of the vector field f, given that f is pi plus qj plus rk. So when you work out everything, you get that partial r partial y is this. Then for this to be rotational, then I component, which is c plus 1, should be 0, so c will be -1. J component, which is 4 minus a will be 4, and k component b minus 2 should be equated to 0, so b equals to 2. So the constants are a, 4, b2, c minus 1. Since f is gradient of phi, and we are supposed to find this value of phi, f can be written as partial f partial xi, partial phi partial y, j plus partial phi partial zk. What is the definition of gradient of phi? So partial f partial phi is x plus 2y plus z. After putting in the constants a, b, and c in the given vector, this is how the I component will be, which is the same as partial f partial x. And then we integrate this partial with respect to x to get the function phi. So phi will be x squared over 2 plus 2xy plus 4xz plus f of yz, where here we are treating f of yz as a function of y, which is a function of y, and z as constant, which turns out to be a function. Then similarly, the j component partial phi partial y is 2x minus 3z. Now to get phi, we integrate with respect to y because the derivative is with respect to y. So phi will be 2xy minus 3yz plus constant, we write as a function of x and z. And then the k component partial phi partial z will be 4x plus minus y squared plus 2z. Then we integrate with respect to z because this is a partial derivative with respect to z to get phi. So phi will be 4xz plus y squared over 2 plus z squared plus a constant, which we write as a function of variables x and y, because integration here was with respect to z. So then now, by combining all these equations which define phi and eliminating redundant terms, then the potential function is given by phi x squared over 2 plus 2xy plus 4xz minus 3yz plus y squared over 2 plus z squared plus c. So show that the vector field F is conservative by finding a potential for it. So here we have directly been told to just find the potential function phi. And if you are able to do that, then it's enough to confirm that the vector field F is conservative. So by definition, F is given by gradient of phi for F to be conservative, or for us to have this potential function phi. So which means the I component of the vector field F is the same as partial phi partial x. So we equate partial phi partial x to I component. And to get phi, if these are derivative with respect to x, we integrate with respect to x. So integrating with respect to x, we get e power x cos y plus xyz plus a constant. But this constant, we write it as a function of now the other two variables, y and z. Similarly, the j component of f will be the same as partial phi partial y, which is xz minus e power x sin y. And to get phi here, we integrate this, but now with respect to the variable y. So integrating with respect to the variable y, we have, or maybe we can as well now equate this one. When we integrate this first function with respect to, we differentiate partially with respect to y, then we will be able to get a partial phi partial y, which we can now equate to this one here to see if we are able to get the value of phi, a value of this function f of yz. And if we do so, we get partial f partial y is 0, so which means that this is just a constant. So for the k component, partial phi partial z is given by this, and then we can differentiate then phi with respect to z and get this one here, and then say that this will be xy times the derivative of a function which is in terms of z, and then which means that the g of z is z squared over 2 plus c. And when you replace g of z in the question which defines g, which defines g of z, then we see that the function phi is e power x cos y plus xyz plus z squared over 2 plus c. Another different way, if this one doesn't make sense, is that just once we have defined this, then equate each of these I, j, k components to this partial phi partial x, partial phi partial y, partial phi partial z, but then integrate to get the functions functions phi, the same way we have done in the previous problem, and then combine all the values, all the expressions defining defining phi, and remove the redundant terms, and then we'll still be able to get this same result that we have here as our phi. Last question 3, find the volume of the parallelepiped whose edges are given by the vectors A, B, and C. Volume of parallelepiped is the same as absolute value of the scalar triple product. So this question is as good as getting the scalar triple product of A, B, and C, and then you get the absolute value of the value of absolute value of the solution. So B cross C by definition is given by this determinant. Get this by cofactor expansion, and you get that B cross C is given by 3i minus 5j minus 7k dot with vector A, and using the normal way of computing the dot product of two vectors, we get the scalar triple product is minus 7, but the volume is given by the absolute value of this scalar triple product, so the absolute value of minus 7 is 7. So 7 is the final answer. B Roman 1, If F is a conservative vector field, prove that the curl of F is the same as 0, which simply means that F is a rotation. This by definition of an irrotational of a conservative vector field F. So consider the curl of F. So curl of F by definition is curl of F is like we are getting the curl on both sides here. Now, it is always known that the curl of phi is always given by 0. So because of this identity, then it means that the left-hand side curl of F is 0, which actually confirms the given result. And similarly, you can also see the solution for this other second part of question 2. And then C, if phi is given by 2xyz squared, F is given by this, and this curve is given parametrically by this functions, we need to evaluate the line integral of phi times dr. So r by definition is given by this, and then get dr dt, from which you can also get dr. Then substitute the expressions into the formula, and then we are integrating from t0 to t equals to 1. So when you combine everything together, you should be able now to find the value of the unknown. Similarly, get f, get dr, get the cross product using this vector definition. And then once you have that, you get now what function to integrate from 0 to 1. And you'll be able to find the value of the line integral. So if A is given by this, evaluate this from 0, 0 to 1, 1 along this given path. So define R, define the R in the usual way, substituting the values from the computed value, and then work out the integral from 0 to 1. Because we're just moving from this point 0, 0 to 0.11. So similarly, you can do the piecewise integration from this point 0, 0 to 1, 0, 0, do from 1, 0, 0 to 1, 1. Similarly, do from 1, 1, 0 to 1, 1, then combine all the parts. And then similarly, you can do where we are now moving along the straight line from point 0, 0 to the point 1, 1, 1. So in summary, that is what you are supposed to do. Kindly go through the solutions and correct the mistakes that you made, so that in the final exam you can respond to the problems correctly. Thank you.